So again, we're starting off with perpendicular bisectors. Use your straight edge to draw a segment, and let's go ahead and label this A, B. Because this is called segment A, right? Okay, so we have a segment here, and ask us to do the perpendicular bisector. Now, perpendicular bisector, okay, actually, I'll have you tell me. What is a perpendicular bisector?
It's when they cross and it makes 90-degree angles.
Pauline, go ahead since you've raised your hand.
I raised both.
A perpendicular bisector is a line segment or ray in a position that's perpendicular to another line segment, and the test is doing the point of the.
Very good. So perpendicular bisector takes a segment, cuts it in half, and is perpendicular to it. Alright, so we have segment AB. And this is how we do a perpendicular bisector. Take your compass, loosen it. And notice it says set your compass for more than half the distance. So just make sure that more than half. And go ahead and lock it in place.
Wait, do you want this at like point A?
More than half the segment. So you can use point A to help you measure.
Yeah, but do you put this at point A?
It doesn't matter, just as long as your compass. I'm taking my compass here, and I want it to be more than half the distance. Again, keep in mind it has to fit on the page, so you don't want to go too extreme with your compass there. And lock it in place. So you tighten it. Sorry, tighten it. You had to loosen it to move it. So then tighten it. Same thing, that one you had to loosen to move on the back side. That.
Don't draw anything yet, Joseph.
So as long as you don't force it. See how it
I don't know, it bothers me sometimes. Joseph, I'm really bad though.
Hey YouTube, back with another YouTube tutorial on how to use a compass 101. You're recording this on the power.
Huh?
Okay, so we have our compass set for more than half the distance, and it's tightened, right? So you cannot easily let it move. Because you can't guarantee that is exactly halfway and exactly perpendicular. This will take care of that. Okay, so we're all set. We have our compass more than halfway. Okay. So now what you're going to do is you're going to take your compass.
That was the yes or no.
You're going to start on point A with the end that is not the pencil. Okay, so your sharp pointy end. Put that on A. And we're going to do a little arc above and below. Okay, so on point A, little arc above and little arc below. Now again, you're not going to get it perfect, but do your best to make sure the compass didn't move, that edge didn't move as you draw it. Okay, so do that for A.
Too much sauce in this compass.
Okay, so a little arc above and a little arc below. Okay, we're going to keep that same distance, so don't adjust your compass, keep it the same, and do the same thing but on B.
Ooh, this is not going to fit on my paper.
Okay, so I come over here, put it on B,
Oh.
and we're going to draw the two little arcs. Now notice how mine intersected nicely down here, but my one up top I didn't go far enough for A, so just go back and fix that for A. Lengthen it out.
Oh, that's it.
What? Why does it do that?
Yeah, neither does mine.
Doesn't like it much.
So they will intersect. If you chose more than halfway, they will intersect.
Why you need a weird looking V?
It's fine if it intersects in the directions. Depending on your length, it might go a little bit into the directions, just as mine did. So we have intersecting arcs here, and again, if yours wasn't long enough for it to intersect, go ahead and go back and lengthen out that A there. Yes. That's great. Alright, so again, we have that intersection above and that intersection below.
That's cool. Maybe I took off one of these.
Okay, now again, things with constructions, it is best to have most of your weight on the end that is anchoring it. So that way, because if you're over here, then you're more likely to lose your spot. So make sure you anchor the end really well. And you don't have to draw huge arcs. Do the little intersecting, little intersecting, little intersecting, little intersecting. If you have massive arcs, massive circles, it's going to be kind of hard for you to see where you're going. Now, as you do this some more, you'll understand about how much you need to draw. Okay? All right, so all we need are these two little intersection points. So take your straight edge. Let's see if I can... I'm going to do it over here. Take your straight edge and connect those 2 points.
Ooh, fancy. Again, all we need are those points from the intersecting arcs.
It's a perpendicular bisector. Oh, that's quite crazy. Oh, no way. I'm not even kidding you. No way. Yes, way, you. Look.
It's not going to let me go. What's that? I know, but I can't figure out. No, that makes it bigger or larger. This flips it upside down, but I know I can move it because there's a degree symbol there. That's right. That's why I have the chalkboard off on the side. Alright, so as we see, this does indeed cut it in half and makes it perpendicular. So go ahead and put those markings in there. You have just created the perpendicular bisector. Yes?
Could just use that line thing, right? Look into that line.
Yeah, I'll mess with it. Okay, so again, we've just done perpendicular bisector. It was really just about 2 steps. So let's recap that, because you're going to have to be able to do this on your own. Take your compass, set it more than half the distance, put it on A, little arc above, little arc below. Keeping that same distance, we do little arc on B, little arc below. The intersection point, connect those, and it's your perpendicular bisector. Okay? Now, remember, what does our perpendicular bisector theorem tell us?
Let's
see if you remember.
Bisectors. Bisect perpendicular.
Perpendicular bisector theorem, what does it tell us?
It sticks.
Something with endpoints and equidistant from the endpoints to the vertices, but we're talking about just perpendicular bisector theorem, so gotta put it together. Ah, here we go.
Oh.
Alright, perpendicular bisector.
What?
Click and drag.
I can't draw with the mouse.
Alright, perpendicular bisector theorem. Who can tell me what it is? You guys have gotten halfway there. Something about endpoints and something about equidistant.
Oh, I remember it. Okay.
Yes, Sam.
And a point that's on the perpendicular bisector is equidistant from both ends.
Very good. Any point that lies on our perpendicular bisector is equidistant from the endpoints. So I want you to go ahead and plot a point on your perpendicular bisector. You can either choose it above or below. I'm just going to go with right here. And now I want you to go ahead and measure that distance from endpoint A to B, and from endpoint A to that point. Let's go ahead, what did it say? Label it C. So let's go ahead and call that C. So choose a point perpendicular bisector and label it C. So go ahead and draw segment AC and segment BC. And then for this part, we're going to go ahead and use the ruler to measure it. And we should see that it is about the same. Now again, we are doing this by hand, so it's not going to be perfect, but you should see that it's pretty close to the same distance.
Oh wait, were we supposed to draw a line with it or no?
Yeah.
I'm gonna try and
It takes so much longer to get all this work.
Alrighty.
What do you know? I said, what do you know? So now your distance is of course going to be different than someone next to you because you guys chose different points. But didn't we get about the same? Was there anyone that got completely off? Good. That means you did your perpendicular bisector correctly. Okay.
So what if the blue stuff is unique? And can we say, well, my compass is same?
Can you say what?
My compass.
No. No. There are some proofs you can do though using the compass. We're just going to be focusing on the two numbers. Okay. So as we just said, when you measure those, you find that these are about the same length, which is our perpendicular bisector theorem. Alright, so as we just said, point C is equidistant from the endpoints A and B. No, it's called point C. 3 dots means therefore. Okay. So again, recapping because you're going to do this 3 times. To do a perpendicular bisector, you set your compass more than halfway. Set it on one endpoint, a little arc above, a little arc below. Other endpoint, a little arc above, a little arc below, connect the intersections.
Cool.
Now you'll notice below there is a triangle drawn for
I
you.
didn't mean to drop it,
It says construct the perpendicular bisector for each side of the triangle below. So you're going to take this one side at a time. Start off with side CA. You can turn your paper if you need to.
oh, we have to.
You're going to take your compass, do the more than halfway, arc above, arc below, arc above, arc below, draw your perpendicular bisector. Again, this is why you don't want to be doing huge arcs and huge circles because then you're just going to have a million lines you're dealing with. So take it one side at a time, draw your perpendicular bisector to the next side. Okay, and you want to be as precise as you can, so that your circumcenter gets as close as we can. Yes, sir. Yeah. Use your pencil to draw. Okay. So I'm going to go ahead and give you some time to go ahead and work that. It's going to take a little while. Just be patient, and I'm going to try to do it up here with the smartboard as well. No. You're not going to be doing the C point. You're just going to be doing your perpendicular bisectors. That's a good question. Okay, if you're still working on your perpendicular bisectors, keep working, you're fine. Maybe. Alright, now again, you might not have yours completely intersecting, depending on how far out your line was drawn, which is fine. I told you that was perfectly okay. Now it asks, do the bisectors intersect at one point? So at this point, if yours aren't already intersecting, such as mine, I can see about where it's going to, but my blue line isn't quite there. Go ahead and extend out your lines so that they do intersect. I didn't want you to get too complicated as you're just getting used to this now. But if you haven't already, go ahead and extend out your lines so that way they do intersect. I'm going to extend out my blue line. And we see that indeed it intersects at one single point. So do the bisectors intersect at one point? By golly, they do. So our answer here is yes. Now we are dealing with perpendicular bisectors, right? So for each of these lines that we just drew, we have it's perpendicular and cuts it in half. We have this is perpendicular and cut this in half. And this is perpendicular and cut this one in half, right? Perpendicular bisectors. All right, it says to label this point here, let's call it P. What is that point called? We've already learned this. What is that point called? The circumcenter. So let's go ahead and write that in our notes here next to P. So circumcenter. And as we know, with perpendicular bisectors, they meet at the circumcenter. And what is that special property it has? Good. Equidistance from the vertices. So for this particular one, we're going to say, we should see that PC is the same as PA, which is the same as PB. So I want you to go and take your ruler. And let's use dashed or dotted lines for this so that you can kind of see the difference between that and your perpendicular bisectors. And I want you to go ahead and draw each of those. Go ahead and draw PA, PC, and PB using dashed lines, and then do your best to measure it with the tools that you've got there. We should find that they are about the same distance. Again, it's not going to be perfect because we're humans and we're not perfect, but we should have it's about the same. How did we do with our circumcenter and our perpendicular bisectors? Were we pretty close? Very good. I'll come around in a moment and check it out. I know it's not easy to do, especially when the compasses can move around and stuff, but patient with it, it usually pays off. Okay, so go ahead and write in what you've discovered about their measurements, even though we already know that it's true, but go and write in that discovery you found.
Your battery's down.
Because it's under forward. Okay. All right, last one. Right. When you measured it, what were the approximate distances you got?
600,000 inches.
Inch and 3/4. Anybody else get around there? Close to 2. All right. Inch and 3/4. I think that's what I got. I can't remember. I'll look at my key. Okay. So what have we discovered about their measures?
An inch and 3/4.
Measure of PA is the same as the measure of PB, which is the same as the measure of PC. And we said they were approximately, what was it, 1 3/4 inch? Very good. Doesn't it feel so nice to have such a beautiful, like, you worked hard to create this picture. This looks super good. Awesome. Yes, sir. It should be pretty close. Yeah, no, that's good. That's very good. I'm sure it is. These look great, guys. I'm so impressed. Okay, so now what we're going to be doing next are angle bisectors. And it's actually a similar process. Oh wait, actually, before we do that, I forgot about this.
What? Ooh,
Okay.
That's a good idea.
So perpendicular bisectors meet at the circumcenter. And it's equidistant from the vertices, right? Let's go ahead and draw that circumcenter. So set your compass so that it's the distance of the point to the vertex. So I want you to set your compass so that it's from point P to your vertex. And then cinch it in place. Tighten it so it's that same distance. Now, as we learned, this should be the radius of the circumscribed circle, the circle that contains that triangle. So, what? Yep, so once you've got it locked in place, go ahead and draw that circle. Oh, mine didn't go as well. And it should be pretty close. I'm going to try mine again. I know sometimes it's kind of hard to see that point of intersection because, well,
Yeah.
you've been using it over and over and over again. I'm going to do it this way. Go. Let's try that.
Okay. Did it.
Okay. And it should be pretty close to that circumscribed circle. Very good. All right. Questions on that? Okay, so again, perpendicular bisectors really was just take it, set it more than halfway, arc above, arc below, arc above, arc below, and connect it. So now let's flip the paper over for angle bisectors. So again, we're going to go back to a bare basic angle bisector. And an angle has not been drawn for you, so you get to go ahead and draw your angle. Use that straight edge that you have. You can choose for it to be obtuse, a cube, whatever you want. Again, keep in mind though, you only have so much space of the paper to work with. Whoops.
Do it.
Oh. I don't want.
There's just draw a triangle.
Draw an angle.
Oh, an angle.
An angle. Any angle.
Fine.
Angle. Draw an angle ABC.
Leg.
A, B, C, D, E, F. G, H, I, K, L, M, N, O, P, Q, R, S, T, U,
Okay. And it says ABC, so let's go ahead and label it as ABC. See. An angle's made up of two rays, right? So just put those little arrows on the ends of their rays. Okay, now we're going to construct the angle bisector. I'm going to draw an angle over here. I'll do an obtuse one over here.
No, obtuses are weird. Just kidding.
Okay, now something I need you to be very careful with as you do your angle bisector is notice how we have A and C on the angle. You don't use those points. That's just to label the angle ABC. So when an angle is given to you and they have those points on the rays, don't use those. You don't need to use those. A lot of students I see will try using those and they get it wrong. Okay. Now again, the instructions here have been given to you, but I'll walk you through it. Use your compass to draw an arc across both rays of your angle, then draw intersecting arcs from those intersection points. So first, take your compass, and you're going to want to make it at a distance so it'll intersect your angle on both sides. Okay, so, nope, that's not too big.
Oh.
I want you to make it so that it'll intersect your angle on both rays. It doesn't matter how big or small. Again, the larger the more accurate, but again, you only have so much space to work with, so be mindful of that. Okay, so just make it so that it'll intersect on both, and go ahead, put your holding end on the vertex, and draw where it intersects on ray A, BA, and on ray BC. So you don't have to do the entire arc, just the little guy there.
Is it a bad thing if you did the entire arc?
You might just have a lot of lines that are kind of hard to keep track of. That's fine. It's fine if it goes through one of the points. I just don't want you to think you have to have it go through one of the points. Okay, so I'm going to cinch mine up a little bit. Okay, so again, you put it on B, put the end, marking end on B, and then just a little arc across A, and a little arc across this one. So I just need where they intersect there. Okay. Alright, so I have my intersection point there and there. So now what you're going to do next is take your compass, and you can actually just leave it at the same distance. If you drew an obtuse angle, you might end up needing to lengthen it. It just needs to be more than halfway the distance there. For most of you, you'll be able to just leave it at the same length. This one I'm going to go and lengthen it a little bit. So if you need to lengthen it some, go ahead and do some tightening. Okay. So now what you do is you take your compass, Okay. You know what? I'm just take your compass, put the holding point on that intersection. Go a little arc above here. And take that holding point, put it on the intersection. And another little arc to where they intersect. So again, you take your compass, move it to that intersection. The little arc above, move it to the other intersection. And the little arc here. I'll redo that one. So you'll have that intersecting point there. A little arc, and an intersection. That point actually lies on your angle bisector. So all we have to do, your angle bisector goes through the vertex, right?
Yeah.
So all you have to do is connect your vertex, that's one point, with this intersection point, and draw your angle bisector. So I want everyone to go ahead and draw in their angle bisector. Alright. Again, it's not going to be exact, but it should be pretty close. Okay. Drawing the angle bisector in. And so as we have here, we have just drawn angle bisector, so these two angles are congruent. Alright, and again, I'm going to make this into a ray here. Okay, so our angle bisector. Now, if you have a protractor ray now, you could see how close you got to halfway. But what we're going to do next is investigate our angle bisector theorem. What does our angle bisector theorem tell us? Remember what our angle bisector theorem tells us. Chandresh? Yeah. Yeah. So any point that lies on my angle bisector is equidistant from the sides, or equidistant from the rays there. And remember, when we talk about equidistance, it's that shortest distance, which is always perpendicular. So it says choose a point on the angle bisector and label it K. So go and pick a point anywhere along here, label it K. And now I need you to make an there's a typo here in your notes, so scribble out, find BC and BA. Alright, so it says choose a point on the angle bisector and label it K. Draw KJ so it is perpendicular to segment BC, and KL so it's perpendicular to BA. Now I'm going to show you how to do that in a moment, because right now you just have a perpendicular, you have a side and a point off of it. You've only learned perpendicular bisector. You haven't learned how to do perpendicular to line. Yes, okay, hold off, wait. Okay, but in your notes here, I want you to go ahead and change this to find KJ and KL. Just want to find that. Okay. Now, I'm going to actually have you come back to this because I want you to practice your angle bisectors. So we'll come back to this so I can show you that next step. But before I throw something else at you, I want you to go and practice your angle bisectors down here on your triangle. So on the triangle down here, go ahead and bisect each of these angles. We're going to be doing what we just did above. Again, recapping what we did, we took our compass and we intersected with our angle on both rays. Then either maintaining that distance or you might have to make it a little bit larger. Go from those intersection points, draw your little arcs intersect, and that's your angle bisector. Okay, so I want you to do that for each of those. I will do the same up here. Alright, again, if you're still working on your angle bisectors of this triangle down here, that's fine, keep working. And you'll see it's not going to be perfect because, again, of human error, but it should be pretty close to intersecting, at one point. So we have this point right here. And it says, do the bisectors intersect at one point? Yes. And again, let's go ahead and label that point P. Now, the next part says to construct the perpendicular lines from P to each of the sides, label the intersections, and then find those distances just like we did before. So what we know is that, well, let's actually go and recap this. So this is angle bisectors. What is that point P actually called? Good, the end center. And what's that special property we have about end centers? Good, equidistant from the sides. Now, as we know, it needs to be that perpendicular to each of the sides. And sure, you could go ahead and kind of guesstimate that, but the whole purpose of the compass and the straight edge is to help get you as close to accurate as possible. So before we go ahead and do that, let's take a look at how to just draw a perpendicular from a line to a plane. And let me actually pass out something first before we do that. So what I'm passing out to you right now is actually a summary of the basic constructions that we'll be doing this year. I want you to hold on to this throughout the entire year because we will be using it in different units and different stingers, as well as we prepare for the SOL. And this is a nice summary of the instructions of how to do what we've done so far, as well as a couple other things. The other things are actually, I think, a little bit easier than what we've done today. Okay, so this pink piece of paper, you see it looks like this. It says Basic Geometric Constructions. So I want you to take this and go ahead and fold it in half, hamburger style. So it says Basic Geometric Constructions is your first page. So it's just like a little booklet, very short booklet, but in half. So on the front side, you'll see these are the 6 different constructions. What we just did was this one here. Oh, it's not telling me right on it. This one here is called your perpendicular bisector. So actually, right above this, go ahead and write in perpendicular bisector above the top right block here. This top right corner one is your perpendicular bisector. That was the first one we did. And then down here is your angle bisector. And it says bisection of an angle, but if you want to write an angle bisector. Those were the 2 that we've done so far. Now, this third one that I'll walk you through real quick is constructing a perpendicular to a line from a point not on the line. So you'll see here they have segment AB, and they have just a point C was given to them, drawing a perpendicular through that. Now, it's not going to be a perpendicular bisector because it's not going to necessarily cut it in half. But any point not on it, we can draw a perpendicular through. Now, inside, when you open it up, gives the actual step-by-step instructions. You'll notice it's just about 3 steps, sometimes 4 steps, to do each of these. So if you forget and you're looking back at trying to how to do it, these give a nice little summary. Also, if you just YouTube real quick construction of a perpendicular bisector, there are plenty of YouTube videos that can give you a quick recap of it. So let's take a look at,
This can be one of the videos.
what's that?
This can be one of the videos.
No, like people have like just a 5-minute video up there. All right, so if you look at the, I think the, wait, nope. Oh, it's the very first one here. So to construct a perpendicular to a line from a point off the line. You'll notice here in the instructions, you're given segment AB and point C that's not on it. And the idea is that you use your compass, you take your compass here, and you adjust it to such a length from C that's going to go past the line so that it intersects it at 2 different points on your line. Then from there, you keep that same distance into the intersection, and that will be your perpendicular line. So let's go ahead and do that with our angle bisector. So if we pull up, we go back here. All right, so let's go back up to the top of our page. So we want to construct the perpendicular from K to side BC and K to side BA. All right, so let's go ahead and do, you can pick whichever one. We'll just do one for right now. So I want to get perpendicular through here. So again, what we do is we take our compass and we set it at a distance so that it goes across BC in a couple different spots. I'm going to shorten this up a little bit. So if you notice here, it's going to cross BC in a couple different spots. So set your compass in such a way from point K to where it intersects the side in a couple different spots. And some of you might need to use your straight edge and extend out the side here. It's fine if you have to. Alright, so again, set your compass so that the holding spot is on K. And then go ahead and draw where it intersects side BC in those 2 spots. Okay, and again, if you need to extend out that line, you can use your straight edge. Alright, once you've done that, go ahead and just keep your compass at the same length. You could change it if you wanted to, but it's not necessary. Leave it at that locked in length. And from those intersection points, you're going to go ahead and draw a little arc to where they intersect. And again, if you have to go back and do more of the arc because you didn't make it go far enough, go ahead and do so. Okay, so we have an intersection here. And again, point K is on that perpendicular line. We're trying to draw a line perpendicular that goes through point K. So we use this intersection of point K, and you can go and draw a perpendicular line. So go ahead and use your straight edge. Match up the intersection point with K. And here we have, this is perpendicular. That point. So it's perpendicular to this side, goes through K. And so thus that is going to be the shortest distance from K to the side. So go ahead and do that with your other side, BA, and then measure those segments, and it should be about the same. Again, you might need to extend out the side. That's perfectly fine, but you're going to want to do that first before you do the perpendicular. And we take your compass. Again, you could use that same distance or change it, but set it at a distance so that it intersects the side in 2 different spots. from those intersections. Draw an intersecting arc. Over here. Oh, I didn't go far enough. Okay. And take your straight edge and go ahead. Draw your intersection there. And again, we have it's perpendicular and passes through the point K. Now, if you measure these distances, they should be about the same, as we know from our angle bisector. Okay. Now, that was what this next part was going to be, was to have you draw the perpendicular for each one, and then measure it and draw that little end center. It doesn't look like we'll have quite enough time for that today, but perhaps if there's a stinger in which we have time. Actually, we have stinger tomorrow, don't we?
No.
Yes.
Yes, we do. Perfect. So make sure you bring this back tomorrow. All right, go ahead and return the compasses and the rulers. And I do have for you your test that you took from before break.